Voila.
Good evening. I'm Catherine Camp, the chair of the Shasta Birding Society, and we are delighted tonight to welcome Catherine Larson. She's a wildlife biologist with the Reading Bureau of Land Management, where she helps make informed land management decisions that benefit birds. She hopes in this position to coordinate with avian biologists along birds' entire flyways and life cycles, and by incorporating citizen science and outdoor education on BLM land. Before serving in this position, Catherine studied wildlife biology at Humboldt State University after transferring from the University of Colorado, where she played softball, rock climbed, and was a whitewater raft guide. When not thinking about birds, Catherine can be found backpacking in the Trinity Alps, cooking and baking, or hanging out with Buddhist monks. So it's a great pleasure, Catherine. Over to you.
Great. Thank you, Catherine.
I have a quick question.
Oh,
Do you want people to ask questions while during your presentation, or you want to hold them to the end, or how do you want to do that?
yeah, I'm flexible. We can do it either way. I might have a hard time. I'm not sure what it'll look like once I share my screen. So if someone wants to maybe let me know if someone has a question, just in case I miss it throughout. But did
Okay,
that
well,
answer your question? You
yeah,
feel free to
we'll
do what you
monitor
like.
the chat.
Okay.
So you can always ask a question in the chat.
Ready? Alrighty. Can everyone see my screen?
yes.
Yep.
Perfect. Yeah, before I begin, just thank you all for coming and listening to me talk about some of this graduate research I did out of Cal Poly Humboldt. I'm really grateful to have you all in this space together and to be able to share some of this work. So today I'll be talking about barn owls and rodents. So you got rodent problems? This is a way to proactively manage rodent pests based on predator-prey ecology. Oh. All right, so in typical kind of presentation format, I'll begin with the background, dive into some field methods and results, then talk about some cost analysis method and results, go into the discussion, and then conclude with some recommendations for managers. So, ecological theory predicts that predators exert top-down effects on their prey by either affecting their prey's abundance and or by affecting their prey's behavior. However, ecological or empirical evidence for these top-down effects is mixed and inconsistent. So, the relative strength of the top-down effects on abundance can vary with things like behavioral avoidance of prey, the functional traits of prey. Meanwhile, the relative strength of top-down effects on their prey's behavior, also commonly referred to as the landscape of fear. So this is kind of a cool concept in ecology that imagines the landscape in terms of spatial variation of the fear that a prey perceives. Um, so that's another word for this behavioral effect. And this can be influenced by the degree to which risk is predictable in the environment, the reliability of cues, and the presence of other predators in the system. So moving on to this point, vegetation abiotic conditions and the functional traits of predators can affect the top-down effect that they have on prey. And so, for example, here. So for example, some predators may hunt better in thick vegetation, like this animal right here, or on bright moonlit nights. Meanwhile, vegetation can also serve to obscure prey. And so I would invite you guys to unmute yourselves. Can anyone see the hidden prey item in this top right image? Shout it out when you know what it is.
Giraffe.
Yeah. Nice, Tobias. There's a giraffe hidden right there. And then vegetation can also serve to obscure prey's ability to quickly escape predators, such as in this example below. Oh yeah, there's a giraffe. So understanding how vegetation mediates direct and indirect effects of predators on prey is especially important where predators may contribute to the control of agricultural pests. A substantial body of literature has examined the effect of predators on insect pests, but far less work has focused on vertebrate pests. This is despite the fact that rodents are among the world's most economically damaging agricultural pests. And crop damage incurred by rodents is estimated at $95.9 million annually in California alone. So the potential for barn owls to contribute to integrated pest management of rodents is especially interesting because they're nearly cosmopolitan. Which means that they can be a solution to many kinds of agricultural systems all over the world. They specialize on rodents, but are flexible enough to consume whichever species is most locally available. So they will stay even during periods when some rodent species are in low abundance. They require more prey than other similar sized predators due to their very fast gut passage times. And they're very tolerant of humans, so they'll readily be attracted to nests and hunt nearby their nest box. So earlier work shows promise that barn owls exert top-down effects on rodent pests. So past graduate student from the lab that I was in, Ashley Hansen, did gopher surveys on vineyards with and without barn owl boxes. And she found that in the absence of barn owl boxes, gopher activity increased by about 18% over the course of the growing season. But in the absence of barn owl boxes, gopher activity decreased by about 14%. However, we still don't know about above ground foraging rodents like voles and mice. Furthermore, very little research has been done to look at both the numerical and behavioral effects that predators have on prey in these agricultural systems. And you might be wondering why growers should care about the behavioral effect that predators have on prey.
No.
So one reason is that it can reduce the amount of time that prey spend foraging, therefore reducing crop damage. It can also cause rodents to make disadvantageous decisions that negatively impact their populations. And so in this study, I investigate whether barn owls exert top-down, indirect or direct effects on above-ground foraging rodents like voles and mice. And I also explore how vegetation cover and abiotic factors mediate barn owl and rodent interactions. This is that top-down effect on abundance and behavior, the effect of vegetation. And then I also simulated the cost and efficacy of using barn owl nest boxes and compared it to estimates of that of lethal trapping to provide growers with more informed land management decisions. So now that we talked about the background, I'll dive into the field methods of this research. The study took place on winegrape vineyards in Napa Valley, California. And while the numerical results of this study are specific to winegrape vineyards, this work can be conceptually applied to all kinds of agricultural systems all over the world. And so I monitored rodents on 3 vineyards with and 3 vineyards without barn owl boxes, both before and during the peak of barn owl hunting pressure. And so this translated to sampling in February and March for this before period, and then in May and June for this during period. And so this before period is the onset of box occupancy and barn owl courtship. And then this during period is when all the young are developing. And so they require a lot of prey items to the nest. And then these are the 3 vineyards with and without barn owl nest boxes in Napa Valley. Let's see, I lost my plot. Okay, so to determine the top-down effect of barn owls on rodent abundance, I deployed these grids of chew blocks where the amount of chew block removed is an index of rodent abundance. And then, oh, so here's some game camera pictures of what the rodents looked like. Not super exciting. But and this is what you can kind of see, this is what the chew block looked like. And then we had these little Tupperware containers on top of them because it was quite rainy in February and March, and that would affect our measurement of grams of chew block removed. And then to determine the top-down effect of barn owls on rodent perceived predation risk, we also deployed grids of something known as giving up density or GUD trays. And so GUD trays were filled with 1 liter of sand and 10 grams of sunflower seeds. And they take advantage of something known as the marginal value theorem, which predicts that an animal will stop foraging when the cost of foraging no longer outweighs the benefit. And so what we would expect is that where there's a lot of barn owls, rodents will stop foraging earlier, thus leaving more seeds in the tray. And then where there's not a lot of barn owls, rodents will continue foraging longer, thus removing more seeds from the tray. And then lastly, another form of rodent behavior that we monitored is rodent activity. And we did this by deploying 72 baited game cameras where the number of photos is an index of rodent activity. So this is an example of what some of those game cam footage looked like. This is a mouse, and then over here is a vole. So as you can see, quite a bit bigger and darker, like some shorter tail. And then here's a little science reprieve for you to show some cool footage of birds, since this is a bird talk. So yeah, this is one bird that we got on a camera. Does anyone want to like shout out what they think it is? I'm not totally sure, but
I was going to ask if that was a barn owl, but it doesn't look like a barn owl. Do you know what it is?
not necessarily. It looks like definitely some kind of raptor, but yeah, I agree. It doesn't really look like an owl.
Interesting. Does have it does have a rounded head. Maybe it is an owl.
Yeah, it could be. I mean, it is at night. Um, this one, I think it's likely a barn owl. Little wing there. And like I said, we got a lot of rain in February and March, so I ended up having some days of swimming in the vineyards, and so did some of these ducks. So these are those game cameras that were supposed to be getting rodents, but We had some waterfowl too. And then, yeah, we had lots of fun with ravens removing a bunch of the bait. They were very smart and they started recognizing me and they would attack me when I would come. And yeah.
Attack you by like flying close to you.
Yeah, they would
Yeah.
swoop down and make a like they had like a whole kind of arm like a little crew and they would like be making all their weird raven noises. And
And they're
yeah,
big.
they are. Yeah. Need a hard hat.
It's some
Got
kind
some
of cat, huh?
cool, yeah, some interesting mammals. Maybe a bobcat.
Yeah.
Question mark. Yeah. Um, they're a small mountain lion or just a feral cat, maybe. So yes, that's the end of the science reprieve. Back to the science. All right. So no, okay. Anyway, so in total we had three response variables. The first is the top-down consumptive effect that barn owls have on an index of rodent abundance. The second is the top-down effect that barn owls have um, on rodent behavior by measuring rodent perceived predation risk and by measuring rodent activity. And so there are three main rodent species in Napa Valley vineyards: deer mice, house mice, and California voles. The vast majority of detections in the study were deer mice, and less than 1% were California voles. And so from March through July, the Johnson Labs Barn Owl team conducts monthly barn owl occupancy checks throughout Napa Valley. Occupancy checks are conducted by placing a GoPro on the end of an extendable pole, as you can see up here, and placing that inside of the nest box. So this is an example of what you just might find on one of these nest box checks. And so these checks were started back in 2014 by graduate student Carrie Went, who initiated all contact with vineyard owners. And 10 years later, the project continues and has grown so that we're now monitoring over 300 nest boxes throughout Napa Valley. And so while I sampled on vineyards with and without barn owl boxes, these monthly occupancy checks made it clear that the mere presence or absence of a nest box might not be the best reflection of barn owl hunting pressure on a vineyard. This is so because several of our vineyards with barn owl boxes either never got the boxes either never got occupied, they were abandoned halfway through the season, or they had low fledgling success. And then on several of our no box vineyards had neighbors close by that had successful barn owl boxes. And okay, this I threw in another science reprieve for you all, so hold that thought. But here's some cool photos from these nest box checks. As you can see, there's like a super young nestling there with the mom still incubating. Oh, also some dead rodents.
So
I just
yeah,
noticed that.
some people probably don't know that barn owls, their young don't all hatch at once. They hatch successfully.
Hmm.
So that you see this owl is sitting on a chick that looks like it's probably 5, 6 days or so more, and there's still eggs under there. So that helps the barn owl. If there's not enough food, then the owlets that are born earlier have most success of survival.
Yeah. Yeah, and you'll see that throughout like several of the photos. You have chicks that are at different developmental stages. Yeah, here's some more fun photos.
Did you guys tag those?
Yeah. So some other people's work involved banding and putting GPS trackers on the barn owls. Um, and yeah, we all kind of got to collaborate on those efforts. So
Cool.
yeah. Someone was taking plumage photos too and comparing different morphs, so like darker versus lighter morph barn owls, and trying to see if they preferred to hunt in different kinds of habitats. Um, More or less in Napa, not so much. I think it's because like the landscape configuration, there's so many different kinds of habitats pretty close by. It's hard to parse out and effect size
So
that study.
the difference in the looks of those uh, different stage barn owls is not, do they actually, are there some actually that, there aren't any that end up with dark facial discs, are there?
Not facial discs, it's more the body plumage right here. Like some will be a lot redder or
Oh,
have like a lot more spots, like larger. And this is an example of a very, very white owl. I don't know if I had. Yeah, I guess I only had white ones. This one, you can see the spots are a bit bigger. Yeah. Here's another video.
ah,
Oh, this is a great example. The two plumages. Yeah.
hey, look like they're the same age.
Yeah.
Wow.
All right. So yeah, I was saying that the presence or absence of barn owl boxes alone isn't a great um indicator of barn owl hunting pressure on a vineyard. And so I ended up creating a continuous predictor variable for barn owl hunting pressure. And to do this, I started with a spatially explicit model that predicts where barn owls prefer to hunt in Napa Valley. And so this is a map of where barn owls are most likely to hunt in Napa. The light colors indicate a high probability of barn owls hunting in that location, whereas the cooler purple colors indicate a low probability of barn owls hunting in that location. Um, this model was updated by past graduate student Samantha Chavez. It was originally created by Geronimo Castaneda, who deployed GPS tracking devices on barn owls back in 2016. And he put them on 11 female barn owls and used 260 hunting locations to create this model. And
Wow.
yeah, so he associated these hunting locations with predictor variables like how far away they are from the nest box, how close they are to certain habitat types. And so what Samantha and Geronimo found is that barn owls prefer to hunt near their nest box, and they prefer to hunt on vineyards that are nearby grasslands and oak savannas. And they also prefer certain landscape characteristics, which is a kind of arbitrary or kind of hard to wrap your head around variables, but things like high edge density, so contrast between two different habitat types, they really like that. And low habitat aggregation. You can think of habitat aggregation as like how clumpy different kinds of habitats are in the entire landscape. And so what I ended up doing was updating this model to reflect barn owl hunting pressure at the time of my rodent sampling. And so to do this, I included in the model which boxes were occupied, how many adults and nestlings were inside of each box, and how old the nestlings were. And this is so because the prey delivery rates change based on the developmental stage of the nestlings. And so here's an example of what this formula looked like, I multiplied the number of adults times the adult feeding rate, estimated to be 10.5 rodents per week. And then I added to this the number of nestlings times the prey delivery rate. Here's an example of a prey delivery. So this was informed by past graduate student Dane St. George, who put these game cameras inside of the nest boxes. And as you can see by this chart, the number of rodents delivered per week to a nest box varies based on how old the nestlings are. And so here's a subsample of what some of these raster layers looked like that ended up being fed into this continuous hunting pressure model. And so here, each row corresponds to a vineyard or a place. And then each column corresponds to a period in time. And then the bright colors indicate high barn owl hunting pressure, and the cooler colors indicate low barn owl hunting pressure. And so as you can see with these methods, I now have a predictor variable that varies both spatially and temporally. And then I also measured various forms of vegetation cover, like vine canopy cover, the height of grasses and forbs, and the amount of dry vine debris growing in between the rows. And then since rodent habitat is abruptly modified when vineyards mow the cover crop rows, that's these that are in between the vine rows, I measured the thickness of grass clippings, which I hereafter refer to as thatch, and induced that a thick layer of thatch is shortly after a mowing event. And so here's some examples of just variation in vegetation types among vineyards and at different periods of time. So as you can see, this vineyard has quite the thatch layer in the vine row itself. It looked like it was recently mowed. Here's a vineyard later on that has a more developed vine canopy. Again, it was probably mowed about a week ago with the layer of thatch. And then I also measured various forms of abiotic factors like lunar illumination and wind. So now we'll move into the results. So I found that barn owls reduced our index of rodent abundance and that our index of rodent abundance increased with more wind. I also found that barn owls increased rodent perceived predation risk, and that rodent perceived predation risk, interestingly, also increased with more vegetation cover. Rodents also perceived more risk in bright moonlit nights and less risk when there was a lot of wind. And then I found that barn owls only decreased rodent activity when there was a thick layer of thatch, those grass clippings. Rodent activity also decreased with more lunar illumination and increased with more wind. All right, now I'll go into the cost methods and results. So as I mentioned, we also simulated the cost and efficacy of using barn owl boxes and compared it to estimates for that of lethal trapping to allow growers to make informed pest management decisions. And so to determine the efficacy of using barn owls, I first determined the number of rodents removed from occupied nest boxes deployed at different densities on the landscape. The number of rodents removed was estimated from Dane St. George's work, who I mentioned earlier. And he found that one barn owl family removes 3,466 rodents per year.
Wow.
Yeah. And then, so the model I used, I updated that model to reflect the fact that from GPS tracking data, we know that barn owls spend about a third of their hunting time in the vineyards themselves versus surrounding habitats, and that about 17% of the barn owl's diet is gophers, and about 83% of their diet is voles and mice. And so as I mentioned, yeah, the metric that I use to calculate this is the cost of deploying barn owl box per rodent per year and the cost of deploying a box per acre per year. And then likewise, I did the same for trapping. And then I estimated this separately for voles and mice or above ground foraging rodents versus gophers because gophers, the trapping method is very different, so the cost is quite a bit different. And then, like I mentioned, barn owls have these rodents represent different proportions of the barn owl's diet, so their efficacy would be different. And so here are the results for gophers, where we have efficacy or percent reduction from a theoretical low, medium, and high initial gopher densities. The bright blue columns indicate a scenario where one barn owl box is deployed per 10 acres. And then this lighter blue is where one barn owl box is deployed every 5 acres, so at a higher density. And then the bright red is the efficacy of lethal trapping. And then above each column is the associated costs of the treatment. And so as you can see, the cost of using barn owls is much cheaper than trapping. However, the efficacy of using barn owls was only comparable to trapping if rodent densities were low. And even when nest boxes were deployed at the highest model density, this 1 per 5 acres, barn owls could not achieve nearly as high an efficacy as rodent trapping does. And then pretty much the same story for voles and mice. As you see, efficacy is pretty even here, not so much at higher densities. And again, the cost is significantly lower for deploying barn owl boxes because you don't have to factor in like labor time. And it's pretty much like a one-time cost, right, of installing a box and then maintaining it. All right, so what does all this mean? Let's dive into the discussion. So bringing this all together, what did we find? Barn owls in the study exerted top-down effects on both rodent abundance and behavior, and results from each of the response variables suggest that vegetation cover favors the acoustically attuned barn owls over their more visually oriented rodent pests. And so farmers use barn owl boxes worldwide to manage rodent pests, and this research contributes to a growing body of evidence for their capacity to meaningfully exert top-down effects in agriculture. In Spain, barn owls reduced vole abundance in alfalfa fields and fruit orchards. They have been shown to reduce abundance of rats in Kenyan maize fields and in palm oil plantations in Malaysia. In Florida sugarcane plantations and elsewhere, installing barn owl boxes inflates the density of barn owls, thus further strengthening their top-down effect. Now, to best understand all of these results, I suggest we consider the functional traits of barn owls and rodents, which impact something known as their Umwelt. So Umwelt comes from a German word that means environment, but specifically in this context is referring to how animals perceive the world around them. So here's a quote that I think emblemates signifies this. So Earth teems with sights and textures, sounds and vibrations, smells and tastes, electric and magnetic fields. But every animal can only tap into a small fraction of reality's fullness. Each is enclosed within its own unique sensory bubble, perceiving but a tiny sliver of an immense world. So I invite you to keep this quote in mind as we discuss the results. So barn owls are known to primarily detect their prey with auditory cues. And so they may have a comparative advantage over their more visually oriented prey where there's a lot of vegetation cover. And these really old 1970s laboratory experiments that studied the neural circuitry of barn owls found that it's much harder for a barn owl to be able to detect and locate pure tones like the squeak of a mouse than it is the rustling of vegetation. And it just so happens that the rustling of vegetation produces sound waves in the frequency most optimal for a barn owl to be able to detect and hunt their prey. Furthermore, the barn owl's strike force is much stronger than their leap or takeoff force. And this is a pretty unique hunting strategy compared to other raptors. Furthermore, compared to similar sized raptors, barn owls have a distinctly long leg morphology, which is thought to, both of these things combined are thought to help barn owls be able to penetrate and strike through thick leaf litter and debris. And so if barn owls do indeed detect and hunt prey most effectively in high vegetation cover, it follows that their prey would also be less abundant, less active, and perceive more risk in these areas, which is exactly what we found. And are consistent with our results, Schultz, Hosted, and Brooks found that in the presence of auditory predators, deer mice and woodland jumping mice avoid habitats with excess leaf litter and prefer sites that dampen their movement-induced noises. Furthermore, these rodents have an innate visual response to aerial predators, and so they likely perceive even greater risk where vegetation cover obscures their ability to detect aerial predators. And this may especially be the case for small, agile deer mice, which again were the primary species detected in the study, who are known to prefer open habitats for fast travel and escape from predators. Okay, now let's dive into some recommendations for growers. So it's important to acknowledge the spatial context of barn owl pest removal services. Nesting barn owls are central place foragers, concentrating their hunting near their nest site to effectively provision their young, with up to 53% of their time spent within 500 meters of their nest box. Nonetheless, their hunting areas are large. And so that GPS tracking data I mentioned found that they will hunt up to 2.86 kilometers away from their nest box. Thus, their pest removal services are spread broadly across a landscape. This is valuable for pest management because the owls can potentially find and respond to local concentrations of rodents. But on the other hand, in heterogeneous landscapes, their wide-ranging behavior may draw owls to hunt in uncultivated habitats in field margins rather than directly in the vineyards themselves. And so future work, such as what a lot of research out of Switzerland is doing, and this is the next grad student in Matt Johnson's lab is doing, is deploying super fine scale GPS tracking devices on barn owls. So these GPS tracking devices are taking, I forget, it's like hundreds of points a second. So it's like it's carving out like the 3D path of a barn owl hunting. It can like specifically see where they're striking prey. And that super fine detail will help to elucidate how this vegetation cover either favors barn owls or rodents a little bit more clearly. And so, given the spatial context of barn owl pest removal services, effective integrated pest management, or IPM, should rely on multiple methods to control rodents. Other more conventional means of killing rodents, like lethal trapping lines or ecologically safe rodenticides, can be more effective at removing rodents in specific locations and or when rodent densities are particularly high. Thus, I recommend that growers target conventional methods based on the reproductive biology and perceived predation risk of the pest species. For instance, just before the young are recruited into the population and where and when rodents perceive the least fear. And then rely on natural predators such as owls, which are a considerably cheaper and less labor-intensive method to maintain a steady removal of rodents from agricultural systems. I also advise that growers manage vegetation to favor barn owl foraging tactics and to elevate the rodents' perceived predation risk. So based on the results of the study, again, largely dominated by deer mice, vegetation grown between the vine rows will likely enhance the top-down effects of owls on rodents, and owls may be most effective when the vine canopy of leaves and the amount of pruned twigs on the ground provide additional cover. Evidence also suggests that the thick thatch layer produced by mowing will enhance the indirect effect that barn owls have on deer mouse activity. And then as I mentioned, barn owls are truly cosmopolitan, and people are putting up these barn owl boxes all over the world. So here's a pretty cool website where you can see live cams of barn owls in nest boxes in several places. And then, of course, all of this work could not be done without the super supportive lab that I was very, very fortunate to be a part of at Humboldt. So this is Matt Johnson's Applied Habitat Ecology Lab, and this lab is all about researching how the ecosystem services and habitat selection of bird species in working lands and agricultural systems. And if you're interested in learning more, there's a lot of great resources on the lab's webpage and Instagram handle, such as the most ideal barn owl nest box placement and maintenance and box designs. And so with that, I would like to thank the funders, the USDA, and Agricultural Research Institute, my advisors, Matt Johnson, Roger Baldwin, and committee member Dan Martin, and then my field techs and good friends now, Molly Heel and Karis Wright, and Bridget, Kelsey, and Em, who helped with monitoring those barn owl boxes. And thank you.
Cool. Thank you.
Yes.
So we have several questions in the chat. Let me go back here to the gallery. So the first question was from Stephanie Hughes. Do all the rodent types do the same amount of damage? What's the damage type?
Oh, yeah. So, gophers are primarily underneath the vines, like in the root systems. They'll gnaw at the roots. And then voles are a particular concern for young vines when they're just trying to get vines growing. They'll just yank all those out. That was kind of the one of the issues with this project is unfortunately, well, depends how you look at it. But yeah, unfortunately, the vast majority of my detections were deer mice, which can cause damage, but it's growers are less concerned about that than they are voles and gophers.
Yeah, I would think that the underground voles and gophers would do more damage eventually to the vines because they're destroying the root system.
Mhm.
Let's see. If not more boxes, what can attract more of the owls to have the desired behavior?
Yeah, so the main thing that the lab has found is that it really depends on the surrounding habitat type. So if you're nearby oak savanna and grasslands, you're more likely to have a barn owl occupy the nest box. They're more likely to hunt nearby and to have more fledgling success. And then with that super fine scale GPS tracking, that will hopefully elucidate some more of those finer scale vegetation characteristics that growers can manipulate for barn owls. So.
Do you know how the presence of great horned owls will affect whether barn owls will take up residence or hunt in the same area? I would think my guess would be great horned owls would not appreciate barn owls in their territory.
Yeah, they definitely dominate barn owls. And they are concerned for like young, if they fledge too early, they could easily get predated on by great horned or even like ravens too are a big problem.
The next question is the approach useful within cities or suburbs? This approach, I assume you mean by
Installing a nest box.
installing nest boxes,
Yeah.
Jackie? Yeah.
Yeah.
Yeah, I would not advise doing that. I guess one big concern is a concept known as an ecological trap. I don't know if you've heard of that, but it's like attracting a species. So you'll give a species a cue, right? That indicates to it, oh, this is a great place to go. I should go here. So the nest box is doing that for barn owls. It's a limiting resource that they need, right, to nest. But if you attract them with that limiting resource, but you attract them to an area that's not good for them, for example, um, there's a lot of power line collisions, a lot of collisions with cars, a lot of environmentally harmful and unsafe rodenticide practices in urban areas. So it's definitely risky to want to attract a barn owl to an area like that. They might use the nest box, but it might not be good for them to do so. Yeah.
Yeah, and I have a comment about that is because I have and there was a photo of one in your presentation. I have one of those plastic barn owl boxes that you can put on a pole, or you can actually fit it into a building with just the face open, and the owls will use it as a box. And I've had it for, I don't know, probably 6 years or more. Haven't seen a barn owl ever. Um, and the reason is, I mean, I have a lot of property, but most of it is treed. So there aren't large spaces of open area land that owls need for foraging. I mean, I've got plenty of rodents, uh, gophers and moles and all those rodents, but my property is mostly trees with a small area, probably a quarter acre maybe of um, unobscured visuals. So if anybody needs a barn owl box, I'm willing to give it up because I've had it for several years and nobody's using it. So if any of you on here, feel free to contact me, webmaster shastabirding.society.org, and I will give you my barn owl box, which is not helping me and not helping the owls. What was the next question? Was does the rodenticide have impact on the owls?
So I am not an expert on this, but due to having been, I guess, exposed to some of this pest management world, I can talk a little bit, not super great details on this. So yes, rodenticide is harmful to owls and pretty much any kind of top apex predator. However, there are ecologically safe forms of rodenticide and ecologically safe ways to apply rodenticide. Like I said, I'm not an expert on this, so I can't give you details, but some of it has to do with the half-life of rodenticide, so how long it's active for within the rodent. And then another is how you apply it in the ecosystem. So um, a lot, pretty much any animal, but rodents also, they'll dig underground to die. anyway. So if you apply it in a safe way and it has a short half-life and the rodent is burrowing underground to die, it's very unlikely to affect an owl. Where you see problems with rodenticide is certain kinds can be worse. And again, I'm not an expert in this, so but certain types of rodenticide are worse, and then the way that they're applied, if you just like leave out a whole bunch everywhere. That's why you typically see farms and growers have specific standards for using rodenticide. So that's why most of the issues that you see is rodenticide in urban areas by like just homeowners that just kind of throw it out there, and it's not the best.
Right.
Interesting.
Let's see. How can these be applied to upland restoration projects?
I mean, I don't see why not. I think it's a great solution. Cavities are a very limited resource in a lot of these upland restoration projects. And I think if the surrounding landscape is good and it can benefit raptors and barn owls, then yeah, go for it. How can it be applied? I guess you can, how? I guess to deploy a barn owl box, you can put it like on a tree too. Um, yeah.
This is a interesting. How did I skip one here? Are they? Oh, are they migratory and what's the
Oh,
usual lifespan? I think barn owls are not very migratory, are they?
not that I'm aware of.
Yeah, I
Um,
think I think once they're there, they pretty much stay there. At least
mhm.
that was my impression on the M Ranch down where I first saw these. That the owls they nested there year after year after year after year once they had a box to nest in. Lynn asked, sort of off topic, do you have a predator prey solution to help the ant to help the ants at my house?
Lynn, I
Yeah.
think you stumped me on that one. What eats ants? Oh no, I'm embarrassed. Um, what does eat ants? An anteater?
Flickers.
Flicker,
Oh,
yeah,
there you go.
flickers,
Birds. More
yeah,
birds.
flickers eat ants like crazy.
Yeah.
So
I'm not so sure
try
you'd
to.
want them pecking through to your attic to get at them.
They're pretty loud too.
You're muted,
Oh,
Lynn. There you go.
oh, also hi, Lynn.
I think you're
You're
still
still
muted.
muted though. Yeah.
Yeah,
There you go. How about that?
yeah, that's better.
There you go. Yeah, there's definitely flickers in the neighborhood, but they're not doing a very good job of eating enough of the ants. So I'm just curious if you might have a solution there, Catherine.
Mhm.
Great presentation, by the way.
Oh, thank
Good job.
you. Thanks for coming.
Absolutely.
So I was going to say that too. That was a great presentation, Catherine. Any last questions, comments, sharing?
Yeah, great presentation. I'm going to stop the recording if there are no more questions.